So for this one, it says, based on the model N 1152. Well, let me just start there. And I'm going to zoom in too. Remember that this is the sample space label, and this is going to be mu, or the mean, and then the standard deviation. That was the notation that were in your notes if you're curious about what the 1152 means. So before I move any further, what I know about this sample is that the mean was 1152. And that the standard deviation for this bad boy is 84. What's so funny?
Just, yep.
My verbiage? Okay.
Yes, I was just like, really.
All right, so now let's finish the question. It says, describing the Angus steers, what are the cutoff values? So now when we talk about cutoff values, the highest 10%, and this is based on the normal model, those are kind of like the cutoff values. So what does that mean? So in a normal distribution, and we're assuming that it's normal because this is about normal distributions. We got the capital letter N for that. So remember that a normal distribution looks like this. A perfectly drawn normal distribution there. And we're interested in this part right here, the area under the curve. Now, you'll hear stats teachers say that a lot. We're talking about what's the cutoff, and it's the highest 10%. Now, if this is 10%, then what's this? 90%. Okay, so the area under the curve, that comes from calculus because you're literally calculating the area under the curve. Now, for you guys, you don't know calculus, so there's a table of these values in the back of the book, but you get those values from doing calculus on this. Anyways, so then the mean right here, this represents the value of 1152. And we're curious about this value here. Well, in other words, what is the cutoff mark for the highest 10%? So the first thing to do is to normalize this. So we're going to find the z-score. So remember, to find the z-score, we say y minus mu. Some textbooks will use x, but it doesn't matter. Y minus mu over sigma, which is still a y value minus 1152 all over 84. Okay? Now, how do I know what the y value is? Because we're really solving for the y value, but I have two variables. I have the z-score and I have the y value. Well, if you look in the back of your book under that table, which was it? Table A, Appendix F, whatever one, Appendix Z, whatever. I think they called it Appendix Z. There's an appendix in the back of the book that has the table of values. And that will yield a z-score of 1.282. Actually, I'm going to move this over here. So you could look up in the back of the book and it'll say 1.282. All right. And that's the z-score. So I'm going to take that value and plug it in here because really I want to know the actual numerical value, and I'm going to do a little trickery here, a little algebra trickery. So I'm going to plug this in for my z-score. 1.282 is equal to y minus 1152 all over 84. Well, gonna need my handy dandy calculator. I have a calculator on my computer, but it is not working properly.
Mister, how do we get 1.282 again?
You look in the table in the back of the book. I can show you, but it gives you right tail, left tail. Did you guys see it? What's the name of the table? I'll pull it up on the screen if you want to see it.
Oh, it's Appendix F.
Appendix F. All right, hold on. I'll pull it up on the screen, and I'll show you where we get the value from. Just give me 1 second. I got to jump in here and get the book on the screen. I had a sneaking suspicion you guys might have a question on that. Did you say Appendix F? Okay. And it's 1.282. Let me just take a screenshot of this and we'll incorporate it. Actually, you could say, well, they used a calculator, but I'll show you. So anyways, let me move my little screen over here. And let me do one more thing here. So I'm just going to paste this right here and I'll show you. So in Appendix F, this is, they have left tail, right tail. So you got to do a little bit of guesswork, okay? So let me zoom in on this and I'll explain what this is. And this will help you where you get that 1.82 from. Now you can use a calculator to do it, and I'll show you how to do that once I get my calculator working on my computer. But I said in our particular scenario, this has got to be 0.9, right? Isn't that 90%? And then that means that this would be the 10% mark, or 0.1. So what I need to do is I need to look for 0.90, right? So I've got 0.9, 0.9. So if you look here, okay, those are the two values. And if you look over here, I've got 1.2. Now, if I scroll up, it's between 0.08 and 0.09. Well, they're very close to each other. Now, if you were to do this on the calculator, it would tell you 2.82. But you could, I would accept 2.85. But this 0.8 means, in other words, this is either going to be, it's going to be between 1.28 or 1.29 because it's in this column or this column. Well, what's in between that? Well, 1.285, but mathematically 1.82 is closer to this side. Does that make sense? Okay. So, but if you were to use 1.285, that would be perfectly acceptable on the test. I'm just waiting for everybody. I got to get the TI calculators for you guys because I'll show you how to do this on the TI.
This page. I thought it was this page because there's 1.282.
Well, there's more. Yeah, so if you do the right, you could do it that way. There's another one where they have the alpha, which is one tail to the right. You could do it that way.
That's 0.1 is right
Which page are you looking at?
A84.
A84.
Uh-huh.
That's in a different. That's not Appendix F, is it?
I don't know. That depends on the,
Huh.
put one or what, right?
Yeah, you could do it. You could do it that way.
Okay.
So yeah, that's a 1 point. Yeah, that's the right tail, left tail. So it's also on A126. So let me show you that. 1 point. So we're looking for one tail of 0.01. Oh, but that's with the degrees of freedom. So we'll come back to that later. Okay.
Yep.
But that would work too. Okay. Well, let me just get it. It's on page what?
A84.
Yeah, we'll come back to that. So on A84, it does the right tail, left tail, which is it tells you exactly what 10% is. What'll happen is you'll start to memorize 10%, 5%. Right, because these values don't change. The z-scores don't change, which is another advantage of this. So anyways, what we're going to do is we're just going to solve this algebraically. I got to solve for y, so what do? What do I do to solve for y? I'm going to have to multiply this side by 84. And whatever I do on one side, I got to do on the other side, right? So this is just basic algebra. So I'm going to take my handy dandy calculator and I'm going to say 84 times 1.282. And that becomes, I'm going to write this over here because I'm running out of room, 107.688 is equal to y equals, or not equals, minus 1152. I need to add 1152 to both sides. And I get y equals, so I'm going to add 1152.
1,259.
59, I think 0.6 is what they had in the back of the book, right?
Hmm?
Yeah, what did it say in the back of the book? They rounded it up to 0.7 because it's 688. So they rounded it up to 0.7. I don't have the entire book in front of me. So what does that mean? We did a lot of work there, but there's a fence right here. So it says, what are the cutoff values? Well, part A says do the highest 10%. So we're just doing the highest 10%. That would be y is greater than or equal to 1259.7. Now, I mean, you could be, I mean, are you going to have are you going to have 0.597 of a, are you going to have a 0.7 of a cow? I mean, I guess you could. All right, so now part B wants us to go ahead and do the same thing, but at 20%. So we're going to do the same thing. So remember that I'm going to draw here because we're running out of space. Normal distribution. I'm going to have to get an image because my freehand is not the greatest. So this is 1152. And for part B, they want the lowest 20%. And so they want all this stuff right here. And this is the lowest 20%. or 0.2000. And so we could go back to that table of, oops, whoa,
0.20.
yep. So now we could go back here and try to find 0.2000, but what do you notice? Uh-oh, we don't have any negative values, right? Because technically, that's a negative z-score. Uh-oh, but good thing this is symmetrical, right, about mu. So really what we got to do is we got to do a little trickery here. Well, the z-score for this 20% will be positive, and then the z-score here will just be the same score but negative. So we just go back, and we've got to find a z-score that is, oh, I got to take another picture because I just took a picture of where I found the stuff. So, actually, it's the page before this, so I'll just take a picture of it, and I'll put it on the screen. So if you go in the back of the book, you'll get something like this. And so what we're looking for is the number between these two, right? Because that's where 0.2 lies. So I was going to try and show you something, but I guess I will do that later. So don't worry about, well, don't worry about the right tail thing. We don't need to do that because your textbook has both left and right tail. But this is what we're looking at right here are these two values because they're the closest to 0.2. And I have a negative z-score. And then the column that those belong in is 0.05 and 0.04. So this is 0.05 and this is 0.04. Okay? Now, what that means is that I'm going to have a value, and the calculator will do this specifically, but it's going to be between negative 0.84 and negative 0.85. And if you were to do it on the calculator, it's going to be a z-score of 0.842. So the fence right here is a z-score of negative 0.842. But we're going to do the exact same thing, right? We want the z-score is equal to y minus mu all over sigma. Well, that's going to be negative 0.842 is equal to y, let me make some room here. Y minus 1152 all over 84. Again, I'm going to hit the left and right with 84. This whole thing gets multiplied by 84. On this the right hand side, I get y equals, or y minus 1152. On my calculator, I'm going to multiply 84 times negative 0.842. That gives me, that yields negative 70. 728. So hard to write with this stupid tablet. Plus 1152. Plus 1152. I bought this with my own money. This is like a $70 tablet. To get the really good ones that look nice, it's way more money. It's ridiculous. So anyway, so I'm going to add 1152 on my handy dandy calculator. And I get 1,081, and I think they rounded it to 0.3. Oh, by the way, we should probably put our units too, right? So if I go back here, so we did all that math. This is in pounds, right? And then now this one would be y is less than or equal to 1,081.3 pounds. Are there any questions on that? Okay, the last one is the middle 40. Are you guys ready? That's a lot of work for this, but it's the same for any type of problem like this. So I need a normal distribution, perfectly drawn normal distribution. The mu is 1152. And they want the middle 40%. So we need to figure this stuff out. So that means that this is 20%, or not 20, 40, it's 30%, right? Because it has to add up to 100. So this is, or add up to 1. So this is 0.4000. This has to add up to 0.2000. And this has to add up to 0.2000. And really, I'm converting it to a decimal, but it's 20% plus 40% plus 20%. So that's 100%.
Isn't it 30%?
Oh, yeah. I'm sorry. I don't know why I'm stuck on 20. Thank you for correcting me. I'm trying to, I'm like you guys. Like, I'm so, like, I'm sitting here going, man, we've spent enough time on this problem. But, yeah, we should probably get the right answer. Otherwise, we're just not, we're not doing ourselves any good. All right. Okay. Yeah, that adds up to 1. I would have caught that when I went to add them all up. All right. So the interesting thing about this is if I find this z-score, I'm going to have the same z-score over here. Okay. Now I think, let me just double check the appendix F. It might give you a two-tail cutoff, but I don't think it does. No, it doesn't. Okay. So basically, we've just got to find the 30%, and it doesn't matter which one, and there'll be one that's positive and one that's negative. So if I look on the table,
30%.
yeah.
Negative 0.536.
Hold on, I'm looking here. I'm just going to put this in the screen so you can see it, and then we'll just write down the value. So what I'm doing is I'm looking for 0.300. So here's 28, 28, 29. Oh, it's right here, right? So it's between these two values. So it's negative 0.5, so now I just got to scroll up to the top. And so it's negative 0.52 or 53, okay? So there's that. And then if you were to do it on the calculator, it's actually 524. So this z-score right here is negative 524. So that's one z-score. And then this z-score is positive 0.524. So now to find the area under the curve, we got to do both of these, right? So I'm going to crank through and do the math on this. So I'm going to say negative 524 is equal to y minus mu, which is minus mu, which is 1152, divided by sigma, which is 84. Again, I'm going to multiply both sides by 84. I get y minus 1152 is equal to whatever this is times 54. So I'm going to say negative 0.524 times 84. And over here, I get negative 44.016. I'm going to add 1152 to both sides. So add 1152. Oh. 1107.984 is equal to y. So that's this cutoff. So this is 1107. They just rounded it up to 1108.0 pounds. So that's the lower boundary, is what we would say. Now we got to do the upper boundary. So we do the exact same thing, but we do it with positive 524. I keep wanting to say 542. So I get y minus 1152 over 84. Tell me what I do next. Multiply by 84. So this time I'm going to get something completely different. So this times 0.542, it'll be the same thing but positive, right? It should be. Let me just do it to make sure. 0.542, 42.
Sorry, 2.4.
Oh, it's 2.4. That's why it wasn't the same. I put it in there. Times 0.524. Yep. Double checking my work. So this is going to be a positive 44.016 is equal to 11, or is equal to y minus 1152. I'm going to add 1152 to both sides.
What about 80?
We canceled out the 84. Yeah, it's all right. Okay, so then this whole thing is 1196.016 is equal to y. So then my upper boundary, they just rounded that one to 1196.0 pounds. Whew, that was a lot of work. So now if I go back for part C, I'm going to write it kind of like this. I'm going to say 1108 is less than or equal to y is less than or equal to 1196. 1196. Does that make sense? Did that help? I think the trick there is using the tables. What's nice, the calculator is really nice, and I'll show you the video on that in a second. It's a lot easier to do it on the calculator, but I think we should probably crank through a few of these by hand first, so you get a really good idea of the area under the curve, the boundaries, and all that stuff. Okay? All right.
So if it's like a few numbers off, don't worry about it, 'cause
Well, I mean, no, we gotta worry about it for sure, because on the AP exam, they're very picky.
well, right, like, I mean, for like, when you're turning the percentage.
Oh, yeah, as you're learning, but we got, okay, I see what you're saying. For now, when we're calculating it by hand, yes, if you were to put in the middle mark, like I did 0.2, but if you were to do like 5, like the midway point between the two numbers, yeah, that's okay.
Okay.
For now. But when I show you how to use your calculator, whatever the calculator says.
Well, yeah, then you can get.
Okay,
the exact
yep.
amount.
All right, cool. Good question. In fact,